Hi all, this is going to be the second part of the video where we show different CloudStack networking models and use cases. This is going to be a somewhat high-level overview. We are not going to actually, let's say, go deeply into how to configure for example, firewall rules or load balancer rules, but we're going to show where they're configured, for example, just to give you a level of how, let's say, deep or actually how high level we are going to do this one. So hopefully you have digested the previous video where we shown you various diagrams like this one, which shows basically advanced shared network in advanced zone, then isolated network in an advanced zone, then VPCs in advanced zone, and finally layer 2 networks in the advanced zone. In this video I'm not going to cover basic zones because these are basically something you can implement or you can do the same kind of thing with the advanced zone. With enable security groups, you can basically have multiple shared networks, so basically like a multiple basic zones. So this is kind of a thing that people are rarely using in very specific cases. I'm going to actually focus on the other networking models that are available in advanced zone, and hopefully show you what are the differences, practical differences beside those theoretical that we already covered in the previous video. So let's start. Let's start with this slide, which is actually a picture showing you an example of a couple of, here specifically two shared networks in the advanced zone. So on this specific example, you can see that basically for a shared network, that's the left one or the right one. Let's focus on the left one. I will leave this one out just for the sake of easier following of the whole thing. So basically we have a virtual router which is only providing DNS and DHCP services to this VM, so they can get their IP addresses. They can use this router as their DNS server unless you configure manually some different DNS server, but all the traffic is routed through external device, and that would be an interface here on the physical gateway, physical router, which is actually now outside of your CloudStack installation. This is the line that basically shows demarcation. The below part is the CloudStack, and the upper part basically is your physical environment outside of CloudStack. Just for the sake of explanation, this whole diagram is showing two different pods. If you have multiple pods, it may happen that one network is available in one pod or the other one in another, but it could be still all the one pod, and you can have multiple shared networks on different VLANs. As you can see over here, VLAN 160, VLAN 161. So you can have different number of shared networks in a single advanced zone. How is this created? In this example, which is not something you would actually want to use in production unless you're using security groups, you are using a public IP range for this shared network. How would you actually create that shared network? You would go to networks, you would click on add network, and then you would go here to shared networks. I tend to keep the name and the description the same, just to ensure there is no differences where, because some parts of the UI might show the name, some parts of the UI might show the description of the network. So I personally tend to keep those the same, but it's up to you. Now, one thing to mention, the only person who can actually create shared network is the cloud administrator. So normal users, normal user role accounts cannot create shared networks. They can create isolated layer 2 and VPCs. They cannot create shared, because shared by definition shared by different tenants. That's the whole idea. So different tenants will see the same network I'm creating as an admin over here. Let's call this something more creative. Something like this, for example. And we need to choose the VLAN, which we need to ensure that we have trunked properly on our switches, and this VLAN actually will provide access to whatever public IP range we define over here to reach internet. So in the case, so if you observe the diagram here, if I wanted to basically simulate this diagram, I would say we are on VLAN 160, so we want to create a network on VLAN 160. Now, for reasons known to me, I will actually choose something completely different, because this is a nested environment that I'm using, and due to avoid some simple issues, I will use an imaginary VLAN. But let's say this is a VLAN 160 as in this example, and I'm going to give a public IP space. I'm not going to give this IP space over here to my VMs. I will use something which is, again, imaginary. It won't be able, those VMs will not be able to actually access internet, but for the sake of demonstration, this is actually not even important. So the gateway, IP4 gateway device will be actually the IP of this physical gateway device. In my case, I will assume this is the IP of my gateway device, which is outside of the CloudStack. This is your physical router, which is providing access to the internet, right? So netmask, let's use standard C class netmask, and you need to define your start and end IP4 IP addresses that will be assigned to your VMs over here. They will be assigned by the DHCP from this virtual router. In my case, I will just say I want to use from .2 until .10. So basically I can spin only well, what this is basically 9 IPs minus 1 IP, which will be assigned to the router itself. That I will be able to spin only up to 8 VMs in this shared network. This is obviously not something you will do in production, but yeah, good enough for the demo purposes. If you're using IPv6, you can specify, remove the IPv4 and then specify IPv6 parameters. And what's also optional as a feature, you can hide the IP address usage as a resource usage if you don't want to bill this to your customers. Some people tend to not bill the public IPs, so yeah, you can actually avoid that. So let's hit OK. And again, I'm reminding you, only cloud administrator is actually able to do that. And now when I actually attach this network to my existing VM, and make it a default one, I'll be making this a default, a default network by clicking the certain buttons. So I will set this as the default NIC, yes, and I will remove this temporarily network that I created because I had to actually create something. Good. So basically my VM, which is now stopped, has only my public network created, and if I actually start the VM, I can actually obviously, well, start the VM, right? So if you go back, this environment is based on the XCP-ng hypervisor. So if I go back to my XCP-ng hypervisor, I can actually see that my VM should be started here on one of these two hosts in a second. And also worth mentioning that there will be a VLAN, and actually it's already there, 3000, the network 3000 created with VLAN 3000 created in XCP-ng. This is still ongoing, so we'll give it a second or two before we actually have a running VM. Here you can actually see the VM is slowly starting, and now actually it's running. All right, we can see the VM is running. This one was started on the second host, and As I mentioned, you can see there is a VLAN 3000 created on top of NIC1 because my physical, that's something I already actually explained in another video. I reference network 1 as the traffic label for the public traffic and guest traffic. But this is important thing is here guest traffic. So this is basically now a network to which my VM is connected, and assuming that my gateway has the proper IP addresses and everything that I set those VMs on boot, they will be able to access the internet through this gateway. That's basically it when it comes to a shared network. There is not much you can actually do with this network. You can obviously edit the network by changing its name and description. You can restart the network. If you do restart with cleanup, this will actually destroy the router and create a new one. I'll briefly do that just to show you that here a new router will be actually created. Here is the new router, R-7, and after this one is fully configured, the old router will be actually deleted. This is called rolling network restart. And actually, as an admin, you can also see that when you go to virtual routers and see there are two routers for the same network. So this is done just to avoid a long downtime by destroying the old one, then waiting until the new one is provisioned. We do it the other way around. We provision a new router, configure everything, and then after it's pretty much ready, we destroy the old router and up the interfaces inside this new router. So that's basically it. All right, well, this is still ongoing. I'm going to continue and move on with a different type of networks. Next type of network that we're going to explain is going to be an isolated network. Now, in this example, I'm showing, in this diagram actually, or this picture, I'm showing 3 different isolated networks. But let's do it like this. Let's focus only on one isolated network, let's say the orange one, so to speak. And let's see what can we do actually, what we can do to provision this network. So again, if I go to network, I can add a network, and as a normal user, I'm also able to do this because this is isolated for a network created for that user. I am indeed doing this as a cloud admin, but I could be able, I could do it actually as a normal user. I'm going to give it not so descriptive name, and that's pretty much all I have to do. Optionally, you can set the IP and basically the network for your internal, for your isolated network. Over here, in our example over here, this network is probably 10.100.100, let's say 0/24. But let's forget this example over here. I will actually rely on the system defaults. I will not enter my gateway netmask. And why is this? Well, if I open just a different tab, same CloudStack installation, but a different tab, if you go to your infrastructure and then to your zone, you can actually see there is a guest CIDR as one of the properties. For some reason, this is set up here on the zone level for historical purposes. So if I don't define my own IP range or CIDR range, this one, default one, will be used, and I'm going to rely on that. This is all I need to do basically. If you want to as a cloud admin, if you want to dedicate that network to a different domain, you can do that, but normal users can create those networks only for themselves. You can also define a network domain, which would be mydomain.com, for example, or anything else. This will be basically a DNS suffix that's appended to your VMs when it gets the IP from the DHCP. So let's actually create this network. I'm not going to dive now into different kind of offerings. These are out of scope for this video, but offerings basically define what kind of network services and are provided and by which kind of device. In our case, it's all virtual router by default. So let's just continue and create this network. When we create this network, it's just in so-called allocated state. The router is not provisioned until we actually attach at least the first VM to this network. So if you go to infrastructure and into routers, you will see there is only a router for our public network, which I'm actually going to change now. I'm going to actually change my instance. I'm going to force stop it just to get things done quicker. I'm going to now attach my VM to this network. You could also, by the way, let's actually do that right now. I'm going to add my isolated network to my VM and make it a default one, and then remove my public network. So here we have a button to set this isolated network as the default one, well, default NIC in this case. And then I can actually remove my public network. I'm basically detaching my VM from my public network and attaching it only to my isolated network. If I start the VM, let's see what will happen. I'm going to show you at the same time here in the hypervisor, basically on the hypervisor level what happens, but I'm also going to show you over here in CloudStack in the virtual router section. So when I hit OK to start my instance, what happens is that CloudStack will detect there is no router for this isolated network, and it will actually create a new router for this isolated network. Then after it's actually configured and created, here we go, that's the new router actually, R-8 created in the hypervisor. Then it will actually configure DHCP reservations, DHCP reservation for this VM specifically, and it will be ready to serve the IP to the VM. After that, only the VM will be started. You can see there is nothing yet happening. There is no VM, user VM created, or my VM is still not started. You don't even see it over here. That's I-2-5 until the router is fully configured. So let's give it a second or two. Right, so router is by now fully configured, and we can actually see our VM being started, and now we'll see a confirmation in the CloudStack as well after a few seconds, I guess. So yeah, here is the VM running, and if you actually go to infrastructure and check your virtual routers, you will see there is a router running over here. Good. If I go to my demo VM, I will see it got the IP address 10.11.94, which you can actually also observe if you go to the NICs. It's 10.11.94. The gateway is the lowest IP of that range. And again, this is because, as I said, we are inheriting the zone level default setting of, where it is, 10.11.0/24, so the very first IP 10.1.1 is assigned to the router, and then basically a random IP is assigned to your isolated network. Now with this isolated network, let me actually delete my other networks, which I don't need anymore, so it doesn't confuse us. With this isolated network, the things are a bit different now. This is how it looks if you observe the diagram. So ignore the blue, ignore this blue example of the tenant. Here there is an example VLAN 201. These are dynamically assigned VLANs for each isolated network from your VLAN range defined for your physical network, where your guest traffic is, here it is, 1241 until 12 1260. So as an admin, you can actually see the VLAN. It assigned the very first, basically, VLAN, and that's also something you can observe here in on the hypervisor side. This is, for example, XCP-ng, but if you go, you can actually see there is a VLAN network with VLAN 1241 created, and then you can actually observe that my VM is attached to this same network. You can see 1241 at the end, VLAN with some UUID, and then the VLAN ID is at the end, 1241. Same is true for the virtual router, because it's also connected to the same network beside the public network, and this is the public network and the control network. So here it is, it's connected to the same network 1241, the same VLAN on the hypervisor side. Inside the VMs, of course, it's not visible. They are not aware of the VLANs they are running on. So this is basically how you create your isolated network. What's interesting now to mention is just a couple of features that are available with your isolated networks. I'm not going to go into details how these actually work, but just to mention what is actually possible. Here you can see that I actually shown on this diagram a different feature used for every different isolated network. Here we are showing port forwarding. On the different tenant we're showing static NAT, and here we are showing external load balancing. This is obviously all possible on a single tenant, and that's something I'm going to show you right now. So before I actually go any further, for this isolated network, in order for our VM to reach outside world, we need to actually configure so-called egress or outgoing rules. In my example, I'm being very generous, and I'm going to basically allow all traffic from my VM to the outside world. And this will ensure that my VM can reach internet basically on its own. Now, these services which I mentioned over here, like port forwarding or static NAT or external load balancing, these are all configured on a specific IP address of the virtual router for this isolated network. What does that mean? That means we will actually, when we go to our network, we are already there, right? This is our network. You are going to get to the public IP address for that network, which is assigned to your router, to your so-called north interface of the router. And here you can actually configure a couple of things. Beside the firewall, which I'm going to explain, we can also configure port forwarding, load balancing, and even remote VPN. So here, let's do a port forwarding. Let's imagine you have a web server running on port 80, and that's something you want to expose. This is basically what you would do. You would define the destination VM for the port forwarding. You would hit OK, and basically now there will be a certain IP table rules configured inside your virtual router over here, but for port 80, which will basically forward traffic directly to that VM in our case. An interesting thing to note here, besides using the same IP address for the port forwarding, we can also configure load balancing. Now imagine I have done something different here. Maybe I've changed actually this to port 22. But for the sake of the demo, let's delete it actually instead of changing it. We can configure load balancing. So imagine you have multiple VMs and you want to configure load balancing. You can basically define public and private ports, algorithm, blah, 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 and so on. More of those details you can actually see in different videos. And then you would choose more than one VM. In my case, I have only one VM, but you don't have a radio button here. You have a checkbox, so you can check the box next to multiple VMs and click OK. And then the load balancing will be configured on top of multiple VMs. And this is actually HA proxy running inside this virtual router where you are configuring on a specific, listening on a specific IP address. That's the load balancing feature. Again, going to delete that one. We can also enable a remote access VPN. This is basically a way for you to VPN into your this is basically a way for you to VPN into your internal network through the virtual router. Imagine this is your office now. You have a router, right, and some servers in your office. So basically you are doing the VPN connection through your public IP of your router. Now, in this case, you will notice, and this is, by the way, imagine I'm doing this as a normal user. This is my, this is my own isolated network. You will be presented with the IPsec pre-shared key, and you can also manage VPN users over here, which is basically you are giving a login credentials, for this VPN. Right, so this is basically how you configure VPN. I'm not going to go into details how you configure this on a client side, but just showing you basically the possibilities, what you can do with your isolated network. Now keep in mind the following: if you have configured, for example, port forwarding on port 80 or load balancing rule on port 80 or whatever port, you need to understand that you also need to allow that port through the firewall. So here, basically we are saying we are allowing, this firewall is, by the way, for the incoming traffic. So you can see now, because my VPN is enabled, the CloudStack has automatically created certain incoming firewall rules. And if I delete or disable basically my remote access VPN, those rules should be revoked from the firewall. But it's not, I believe it's not the same. You see now the rules are gone. If you do port forwarding, those rules will not be automatically created. Let's try that just now. So we are doing port forwarding to an internal VM. And once it's done, if we check the firewall tab, there is nothing over here. So even though you have configured now your port forwarding, your access to this public IP over here will not work. Obviously, notice this is not really a public IP. This is my demo environment, but it does serve its purpose. So you do actually need to define that you are allowing traffic from any remote IP, which is this one. You are allowing TCP on port 80, or you are maybe allowing something else. And basically, once you get your firewall rule created, only now you will be able to actually access this public IP on port 80, which will do the port forwarding to internal VM on this IP address. Same goes for the load balancing. After you create a rule, you need to ensure there is a firewall rule as well. And that's pretty much it when it comes to the isolated networks. For the isolated networks, you can obviously, as I mentioned, even with shared networks, you can change a couple of things, edit the isolated network, including the domain for your VM, or you can restart your network with or without cleanup. With cleanup, it will, as I mentioned, delete the old router and make a new one. If you suspect there are issues with the old router of any kind, you can tick the cleanup button, click OK, and then a new router will be created and the old one will be destroyed. Right, moving to VPCs. VPCs are basically an evolution of your regular isolated networks. Basically, with isolated networks, if you check the diagram, you have only a single network. This is a single network with multiple VMs behind the router. Now, at some point, people have expanded this to actually create multiple networks. Let's again focus on the orange tenant, the VPC number 1. You can have multiple networks behind your router. So this one is the network on VLAN 300, on VLAN 301, 302. I should probably have colored this in a bit different color just to show it's actually different networks, but obviously you see the VLANs. So these are completely different networks, and if a VM in this network in VLAN 300 wants to communicate with a VM with VLAN 301, it will go through the router, as you can obviously or hopefully see from the diagram. So let's do that. With VPC, when you create a VPC, again, give it some meaningful name for your case. We need to define what's called super CIDR, or the CIDR for the whole VPC. When you create later networks inside this VPC, those networks needs to be a subnet of this CIDR. So I will make this very generous 10.0.0.0/8, which is actually not something you probably do in production because it's really huge network. Again, the domain name will be you can leave it blank obviously, or you can add some domain like this one. You certainly remember this from the old days, and then your VMs will have DNS suffix of the name of the VM dot this domain over here. I'm going to leave it empty for now. So once you click create VPC, in contrast to isolate network, it will actually go and immediately, here you can see, create a new router and start it. Now the difference is there are no networks attached to this router. So if you actually go to the networking tab, you can see, well, this is not fully configured, but you will see it's only connected to a public and the control basically network. After it's actually fully provisioned, it's still basically booting. Their CloudStack is configuring certain rules and so on and so forth. Good. Let's give it a second or two until this is actually created. All right, so you can see that my VPC was successfully created. If you observe it on the hypervisor side, you can actually see that this router, which is now created and running for our VPC, router number 9, has basic network cards connected to two different networks: the control network, which we're not going to explain in detail, and my public network on VL151. Now, I obviously need to create now inside the VPC, you need to actually create at least some networks before you can actually attach your VM to those networks and thus attach the basic to a VPC. So I'm going to add a network. I'm going to call it VPC net number 1. Again, not very descriptive, but in your case you can do different things. Now here comes what some will find a slightly tricky part. You need to define a gateway and the net mask. These two together will basically define the network of the CIDR range of this network. And the gateway is actually the IP that will be assigned to your virtual router for that VPC. So here I will use this example just to show you how easy it is actually, and we'll use standard C-mask, C-class netmask. Default ACL, I will explain more about the ACL, but for now leave it as default allow, which is allowing basically outgoing traffic from this network to the outside world. Now, for the sake of demo, we will create additional network and give it a slightly different net mask. All right, I'm just trying to see if I made a mistake over here. No, I did do a good gateway. All right. Sorry for this. All right, let's create another network. As I said, this will be VPC number 2. The gateway, the address of that we want to assign to a router will be this one, for example. And again, leave the default ACL. Now you can see we have two different subnets for our two different networks created, and they are all subnets of a larger VPC, which is 10.0.0/8. So again, wrong picture. All right, so basically we have created two of these networks. Now in this example you can see, let's just focus on this single let's say VPC. In this example we have three networks over here. We have created only two, and these are on VLAN 300 and 301 in our case, and in general these are automatically assigned by the system from the pool of the VLANs defined. So basically, as an admin, if you go to networks, you will now, beside that isolated network which we previously explained, now you will see our two VPC networks. Now the reason they don't still have their VLAN assigned is because there is no VM yet attached to those networks, which we're going to actually fix right now. I'm going to, by the way, you can attach your running VM to additional networks, but you cannot really do some other things, so that's why I like to actually just forestop it for the sake of demo. But yes, you can attach it while the VM is still running. Let's go to NICs and let's add a NIC from those two networks. VPC number 1, all right. And again from VPC number 2. Just an interesting thing to notice, if you go now to your hypervisor, oops, it's not running, so that's fine. I'll make one of these a default one and remove my isolated network just for the sake of demo, so that we can also delete the isolated network actually. So I'm detaching my isolated network NIC from my isolated network to the VM. Right, but it has, as it says, port forwarding or load balancer or static rules configured, so we cannot actually do that immediately. Let's first delete those rules. And I believe now we should be okay to actually detach the VM from this network. Yes, so we have successfully detached it, and now I'm going to actually start this instance to show you what will actually happen on the hypervisor side. So if you go, we are starting a VM, you can see now that there is the router is attached to a VLAN with ID 1246, and a couple of seconds later it will attach to another VLAN as well, because it has two networks. There are two networks basically here that we have created, and again going back to this hypervisor basically tool, you see those are the two VLANs 1246 and 1258. If you go back actually to your list of networks, you can actually see those 1246, 1258, which the VLANs which are assigned. And again, only Cloud Admin can see this, not regular users. They only see their networks and they can consume it. All right, so a couple of features which are specific to a VPC. If you go to your VPC and you, let's actually first explain the differences between firewall and ACL. So with isolated networks, we saw that we actually need to enable firewall before or after, let's say we configure a port forwarding rule or a load balancing rule. Now with VPCs, because we are having multiple networks behind the router, we now don't call this anymore firewall, we call it ACLs, like in a normal, let's say, enterprise world. And here are the network ACLs. If you go to your My VPC, you would go to the list of the network ACLs, where you can, for example, create a new ACL, and then later you assign this ACL to your network. So for example, we can, just for the sake of example, we can create an ACL that, for example, gives access or allows, let's say, VMs to only ping internet or, let's say, Google DNS servers. So this is rule number 1. now it's interesting to explain when you observe the CIDR list, what this actually means. Is it a destination or a source CIDR? It depends on the kind of traffic type you want to define in this rule. In this rule, I want to define egress or outgoing traffic. So I basically want to allow outgoing traffic to Google public DNS servers to ping them, that's all. So basically, whatever I defined over here in the CIDR list, because it's egress rule, this means destination. So my destination will be 888/32. To be honest, I'm not sure if I should add /32, but let's see. The protocol will be ICMP, and we are going to allow to use -1 to allow all kind of ICMP messages. And we will give it some explanation. Right, so basically here we have rule number 1, which is allowing basically the UI is a bit let's say not so weird. There is a lot of spaces between these columns, so it's broken in 2 rows, but it actually should be 1 row, just showing you a single rule. And then we will add another ACL that actually blocks all outgoing traffic. This will be rule number 2. We will block traffic to everything else. Again, egress traffic we want to deny all. So rule number 2 is an egress rule, outgoing rule, which denies traffic to all destinations, which this means all protocols and so on. You can call it default deny rule, for example. Hit OK, and this is the one. So basically this works now the same way you would expect it to work in any firewall. If the traffic matches the first rule, it's applied and there is no further processing down the stream in the firewall on the inside of the router. But if we try to ping, let's say 4.4.4.4, then this rule will not match our destination, and we will fall back to a default rule. This rule will match it, and this rule says deny, so no traffic other than the ICMP to this IP will be allowed. Now we created our ACL. Again, let's go back to the VPC network access list. We have 2 default ones and we have our custom one. Now we have just created this as an entity, an ACL with a set of rules, but we want to actually now assign this to a specific network. So if we go to our network, we can actually click on it, and there will be a button, replace ACL. Currently, you can actually see there is the default allow ACL, which is applying to this network, which allows pretty much everything. I want to replace this with my own ACL. So I'm actually here restricting outgoing access to my VMs, and obviously there is no incoming access defined, so it will not work. Now any VMs attached to this network will be able to only will be basically following the ACL rules defined over here. Good, let's move forward with VPC specific features. Those were the network ACLs. We can also basically on the IP address, this is the public IP address as it says, we can actually do a couple of things. On the default public IP address, you can only enable remote access VPN. If you want to actually consume some of these external services which also exists in the isolated network, like port forwarding or load balancing, you will actually have to assign additional IP addresses. So let's go back. Actually, let's use the back button. It's a bit more convenient. So public IP, I will acquire a new IP for port forwarding rule, for example. Not sure if I actually click that button. And then I will get yet another one for my load balancing. And and I will get yet another one for my static NAT, just to show you those things. So let's use the lowest one, for example. You can see here we can configure either port forwarding or load balancing. So if you configure port forwarding, you will not be able to configure any more load balancing. So please observe, once I create this rule, the load balancing tab will disappear. So I'm creating my port forwarding. Oops, sorry. This is a bug that is actually solved in the newer releases. We need to specify in which network we want to search for a VM, so it actually do a port forward to a different IP address of the VM. Once we do this, the load balancing will be gone, so that's something you need to understand. When you are using VPC, there is no conserve mode, so basically for every different network rule, you have to have a dedicated IP address. So if you go back to our public IP addresses of our VPC over here, we can go to the next one. Again, if we configure load balancing, we are basically only using that feature, and the firewall will be, you choose the network where you want, let's say to this IP over here, and basically the port forwarding rule option to actually create to port forwarding rules will be gone, as you can see. Finally, thing that's worth mentioning is the static NAT, which can be configured on a dedicated IP address. Let's go back actually. Public IP addresses 206, which is not used anymore. It's a bit hidden over here, so you can enable static NAT for a specific VM. What does it mean really? I'm just now enabling it. So all the traffic that comes to this public IP on any of the 65,000 and some more ports will be basically sent to this internal IP address of the VM. Just a second, my UI seems to stop working. Right, this is the static NAT IP which we did. And also worth mentioning, if this VM just accesses internet on its own, it will be represented to the outer world, not by the default IP that the other VMs would be by definition, but it will be represented to by this dedicated IP address. So beside forwarding all the traffic which comes to this IP to our VM internal IP, also there is the other way around. The outgoing NAT is created using this IP address over here. So if you go, imagine this is a Windows VM, you open your browser, you go to the website whatismyipaddress.org, it will show you theoretically this IP address. Obviously this is a demo, not really a public one, but it will show you this one, static NAT IP, not the default one, which is so-called source NAT IP. So those are different things you can do with your some of the different things you can do with your VM with your VPC. Sorry. Now an interesting thing here that we saw, which is different from isolated networks, is that you also have the possibility to create site-to-site VPN, and you can also have the possibility to create private gateways. I'm going just to do a high-level touch of these, and maybe we can do a dedicated video later on. We'll see. So the site-to-site VPN is always created or configured using the default IP address. If you go to the VPN tab, this is actually this is my bad. It's actually created over here. This is the new UI, which, to be honest, I'm rarely using. It's actually just been out for a couple of months, but yeah, it's on a different place in this new UI. So if you want to create site-to-site VPN connection, you actually cannot do that immediately. You first need to create your VPN gateway. and then actually create VPN gateway and VPN customer gateway, and then later create the connection itself. So the step is 3 ways, but that's basically, this is the place where you define all the different parameters, including the custom pre-shared key, phase 1, phase 2 parameters, list of the remote subnets as it says over here. By definition, the list of local subnets is the whole CIDR range of your VPC. Once you configure your VPN customer gateway, you would configure this with the same parameters, just always a different remote subnet. On the other side, on the other remote VPN device, after you configure this one, you would actually go into your VPC and enable your VPN gateway, which we just did previously. Let me, oops. And after that, you can actually go into your VPN connection and create site-to-site connection using your VPN customer gateway. But again, this is something you create previously. So this is the remote. This is the site-to-site connection using standard IPsec suite of protocols. And the standard again, you know, phase 1, phase 2, IK 1, IK 2, and so on, configurations. So that's the site-to-site VPN that we are showing over here. And now also there is something called private gateway, basically functionality. So again, if you go to your VPC, you have your private gateway. Now this is something that only cloud administrator can configure for other users actually. Why? Well, because when you add a private gateway, you need to specify a specific VLAN that you know you have previously configured on your physical switches. So the idea is that you have a remote fiber or remote cable, basically from a remote routing device coming into your environment, into one of your switches, let's say on VLAN 3001. So that's basically what you define here as VLAN. You give the IP address, which will become the IP address of the network card inside our virtual router. You define the gateway, which is basically the remote IP and the net mask, and assign a certain ACL. You would click OK, and then later you have option to create routes so the traffic can actually happen. Again, going back to this diagram, the idea is that the traffic between the virtual router and this remote router, which might be, you know, somewhere near this one, physically in your data center or a bit remote, the traffic is happening over a private, dedicated, let's call it dark fiber. It's not going over the internet via the IPsec tunnel, which is, you know, secure, but it's still going over the internet. Here you can have a gigabit or multi-gigabit line, for example, and consume this directly. So those are a couple of things you can do actually with VPC, and of course you can always restart your VPC again with a cleanup option, which will ensure that a new virtual router is created. If you assume that the current one has any issues, that's something you can do. A new router will be created and the old one will be deleted. Right, so that's all for the VPC for now. And finally, we have one last kind of networks, which is which is the so-called layer 2 network. The idea with layer 2, as I already explained, is that you have your VLAN basically kind of provisioned across your hypervisors. And you have VMs created and you can manage your VMs, but there is no virtual router. So you need to ensure that you bring your own device, which will provide IP address management or DNS resolution, routing, and other network services. So there is no network services whatsoever created or provided by any kind of appliance like virtual router. How you do this with CloudStack? Again, you would go to guest network, you would add a network, and you would choose a layer 2 network. We will give it a descriptive name or hopefully somewhat descriptive name. Again, I'm not going to dive into offerings this moment, but yeah, based on some of the offerings, you will create your layer 2 network, hit OK, and it's kind of created, but it's still only allocated, which means it's just a database entry. Only when you actually assign, and let's do this while the VM is still running. I'm going, by the way, to bring up here the hypervisor just to show basically the networks which exists here. We can now see quite a few networks actually in our case, but let's observe just the networks to which this user VM is attached. This is our demo VM E25. This is E25. So I'm going to go to the NICs and add the network. That's my layer 2 network. Hit OK, and basically you will see now in a few seconds there is an all right, we have some kind of failure. There is basically a network created, and that's this network with 1256 as the VLAN ID, which is provisioned, and the network card is created inside the VM to actually basically put it over here. Now I am using somewhat newer very new hypervisor and extremely old operating system template, which is CentOS 5.6. So I'm assuming that failed due to that. So let's just try to stop the instance briefly and try to attach. Now it's stopped. I'm going to touch it again, and this one hopefully should work. And yes, it does. And then we can start the VM, and that's pretty much it. The VM will appear just in a second over here. Actually, when the VM is starting, all these DHCP reservations inside your virtual routers to which basically your VM is connected needs to be provisioned, so all the DHCP stuff, so it takes a bit of time. But either way, here it is, the VM is started, and again, just to confirm, it's actually connected to 1246 VLAN, which is this first one. Actually, I'm not sure if it's visible over here. It is indeed. Then we have it connected to our 1258, which is the VPC net number 2. And finally, we have it connected to 1256, which is our layer 2 network. Now keep in mind, if you attach your VM only to layer 2 network, it will boot or should boot successfully, obviously, but there will be no IP address assigned to this VM. As I mentioned and already explained in this graphic, there is no virtual router which would provide IP address or DNS resolution. So this is kind of a special case that some companies might need if they want to bring their own physical equipment and they don't want to have virtual router whatsoever. And that's pretty much it when it comes to the layer 2 networks. You can't actually really restart it. There is nothing to be restarted over here, although I suspect, yeah, as you can see, there is no restart button actually, so there is nothing to do. You can only delete the network, but of course only if there are no VMs attached to this network. And that's pretty much it for this video. It's been quite a long one, but I hope you now have a feeling or an overview of how different things are configured and what are the differences between different kind of networks, shared networks, isolated networks, VPCs, and layer 2 networks at the end. Thank you for watching, and see you next time.